In today's video, I will demonstrate a method to determine the scale speed in miles per hour for any model train. Now, my layout is Lionel Legacy. I have Lionel Legacy control, Lionel Legacy engines, and as you all probably know, Lionel doesn't give you scale miles per hour speed. Not on the controller, not as far as I know on the app, although everything's changing with them with the base 3 coming out. But up until now, MPH has always had scale miles per hour, and Lionel hasn't. I don't know if that's a patent thing or what, but I'm someone who's interested in that, and since I have a Lionel layout, I had to come up with a method to determine scale speed. So I'm going to show that method. It takes a bunch of calculations to start, but in the end, I'm going to show you a simple calculation, one calculation. You're going to have a magic number based on the length of your track that you're measuring the speed. You're going to divide that number by the number of seconds it takes for the train to traverse that piece of track, and that's going to be scale miles per hour. And for added fun, I just recently purchased my first DCS locomotive. Pardon me. I got this Atlas O-scale 3-rail Amtrak P42. I love it. And in order to run it, I had to get a DCS Explorer and the app. And of course, it shows you scale miles per hour. So what we'll be able to do is, first I'm going to show you the method to determine this mathematically when you don't have scale miles per hour. That is, if you have Lionel Legacy or something else. And then we'll test it, or we'll test MPH's accuracy by running this train and measuring the miles per hour and see if it matches what MPH says the train is running at. Okay, let's get started. So first you need to pick out a convenient piece of track that you're going to measure the train on. I chose two 30-inch straight tracks, Lionel Fast Track. And just to be accurate, I measured, not that I don't take Lionel's word for it, but I measured it, and it is actually 60 inches. So this is a 60-inch run of straight track. We're going to measure the train. We're going to start, yes, we're going to start timing it when it reaches the beginning of the straight track. We're going to stop the timer when it reaches the end of the straight track, and then we're going to use the calculations. So let's go over the calculations first. Okay, as you can see, I've got the Atlas O engine running at 25 miles per hour according to MPH, DCS. And the next thing I'm going to do is time the train. Okay, let's do some math. So, O scale. What does it mean? O scale is 1/48 scale. That means 1 foot equals 48 feet, or 1 inch equals 48 inches. Therefore, 1 inch equals 4 feet. And that's the key conversion we need. So, we had a length of track that was 60 inches. We're going to multiply that by something that has feet in the numerator and inches in the denominator, so that inches cancel out. So there's obviously, according to O scale, 4 feet in 1 inch. 60 times 4 divided by 1, 240. Inches cancel, that's feet. So that track is a scale 240 feet. Now, the next thing is, how much of a mile is 240 feet? So we multiply 240 feet by something that has miles in the numerator, feet in the denominator, and obviously 5,280 feet is 1 mile. Feet cancel, 240 divided by 5280, 0.045. We'll stop there, mile. So we know what distance the train traveled in feet. We converted it to miles. Now we know how long it took in seconds, 6.39 seconds. So now we just have to say 6.39 seconds per 0.045 miles is how many miles per hour. Again, you use conversion factors. You have 0.045 mile in 6.39 seconds times something that has seconds per hour. 3,600 seconds in 1 hour. The reason is we want seconds to cancel out so that our answer will be in miles per hour. So we've got the distance traveled over the time times a conversion factor that converts seconds to hours. We already know how many miles, so we'll have the answer will be MPH right here. So let's do that. 0.045 times 3,600, and then divide that by the time it took the train to travel that distance, 6.39 seconds. Our answer, 25.3 miles an hour. What does this mean? This means that MTH is very accurate. Obviously, there's a margin of error because I eyeballed when the train started the track and when it finished the track. I don't have light beams that a train can break to make it super accurate. So there's a little bit of error in when I start the clock and when I stop it. Very small amount because the train wasn't traveling fast. The faster the train is going, the more error there will be in doing it simply by eye. But at that speed, there's not that much error, wouldn't think. So we calculated 25.3 miles an hour, and MTH DCS app said 25 miles per hour. I'd say that's very accurate. So now we know we can trust that. But if you don't have MTH, if you have Lionel or another brand that doesn't give you scale miles per hour, you need to do the conversion. And we can simplify this whole thing into one simple, what I would call a magic number. And that magic number is the number that you'll divide by the number of seconds the train takes to traverse the distance, and you'll have miles per hour. One simple equation. I'm going to do it for my distance, which is 60 inches, but you can change the math if you have a different distance. So what you're going to say is there's 3,600 seconds in an hour. You're going to multiply that by 0.045 miles, which is how far the train went. Divide the whole thing by the number of seconds it took to go that distance. And this is nice because, once again, seconds cancel out and leave miles per hour. So again, this was 6. So let's forget the specifics in this case. Let's get the magic number. 3,600 times 0.045. So the magic number for a model train traveling 60 inches on an O scale layout is 162. That means that whatever time you get when you measure the train traveling those 60 inches of O scale track, you divide that into 162 and you'll get your miles per hour in speed. Again, in our case, we had 6.39 seconds, and that will come out to 25.3 miles per hour. So if you're using 60 inches and it's O scale, just remember 162. Measure the time it takes to travel the 60 inches, divide 162 by that number of seconds, and you will have miles per hour. And that's the simplest way to do it, I think. Lionel used to sell this big contraption that was like a crossover over the tracks that would measure. I have one somewhere that measure miles per hour, but I saw another YouTuber test one out. It didn't seem to work. So I think that this method is much more accurate. And it's nice to see that since I just got my first DCS train, it's nice to know that the scale miles per hour that they're showing is actually accurate. Anyway, hope you enjoyed that.